Okay, we have here today another integral from the Scranton integration bee 2017. This was problem 15. We have the integral from 0 to pi of sine 2x over 2 plus cos x dx. Okay, the thing I noticed first here is just that we've got a different angle on the sine and cosine, which makes it just a little bit tricky to work with. What I can do here is I can use the double angle formula for sine to rewrite that. So this here, sine of 2x is the same thing. We can write this as 2 sine x cos x. So when I rewrite my integral and I write it with this, I'm going to bring a 2 out front. I'm going to bring this 2 out front of the integral here. We'll write the numerator as sine x cos x, but I'm just going to change the order just to set this up a little easier for myself. And then I'm just going to copy down this denominator, and then we can continue. And then at this point, because we have cosine here and we have sine here, this looks pretty good for a u substitution. I actually on paper did this two ways. I substituted u as cosine of x, but I think what's going to work a little better maybe is if I make u this whole denominator here. So let's see how it goes. We'll say u is going to be 2 plus cos x. I'll take my derivative. Now du is going to be, the derivative of 2 is going to be 0. Derivative of cosine is going to be minus sine x dx. And now if I just take this sine x here and I multiply by a negative 1, well then now we have our du right here. We have our u here. Now for cosine x, what I can do is just take this and solve for cosine x by subtracting 2. So we can say that cosine x is going to be the same thing as u minus 2. Sorry, one thing I forgot is I multiplied by a minus 1 to make it match this, but I forgot to multiply by minus 1 out front so that I'm not changing the integral. So now I'll go ahead and we'll make this substitution. And so what I'm going to do is we're going to take pi, plug it in here. Cosine of pi is minus 1. 2 minus 1 gives me 1 for the upper bound. Then plugging in is 0. Cosine of 0 is 1, plus 2 gives me 3 for the lower bound. Then here, cosine of x, we just found this value, u minus 2. Then this whole piece is going to be our du, and then we're going to have just u in the denominator. Next, what I'm going to do is take this minus sign, use it to flip the bounds. We kind of just prefer to have the larger number as the upper bound. Now from here, what I'm going to do is just going to take this u in the denominator, divide it into the numerator. And when I do this, I can actually split this into two integrals. Now dividing u into u is just going to give me 1 for the first integral. And then for the second one, I'm going to take this minus 2 and bring it out front and multiply it times this 2. So I'm going to have a minus 4 in front here. And then we're going to have just du over the u. And then I'm ready to integrate. So this one is just going to integrate to u, evaluated from 1 to 3. And then here, integral of du over u is going to be just natural log of absolute value u, and we're just evaluating that from 1 to 3. So now just evaluating this, plugging in a 3, we're going to have 2 times 3, we're going to have 6. Plugging in a 1, we're going to have a minus 2 here. Then I'm just going to keep my minus 4 here out front. Then here I'm going to have natural log, plugging in 3, we're going to have natural log of 3 minus natural log of 1. Natural log of 1 is just 0. So for our final solution, we're just going to have 4 minus 4 natural log of 3. So there you have it. Not too hard. Pretty good problem. So I'll stop it there. Thanks everyone for watching today. Have a great day.